And welcome back to the video lectures on replacement models. So let us move on to the next model of uh, model 1, or move on to the next case of model 1, which is considering changes in value of money with time. So first let us understand what is the concept of value of money. If we invest an amount of 1 rupee today, then it it will become 1 plus I after 1 year. So 1 rupee invested today will be incremented to 1 plus I, where this I is the interest on 1 rupee. So the value of a rupee increases after 1 year. Similarly, after n years, the value of 1 rupee will increase to 1 plus I raised to n, because after 2 years it will be 1 plus I square. After 3 years it will be 1 plus I cube, and so on, and hence finally after n years it will become 1 plus I raised to n. And if you see the opposite situation, if we make a payment of 1 rupee after n years, then we will be paying today an amount equals to 1 plus I raised to minus n. Okay, so we have simply taken this term on that side. This is the meaning of this statement. Okay. Okay. So hence the present value of money spent after n years can be calculated by using this formula, and this 1 plus I we are going to represent by a small letter v, where the small v is 1 plus I raised to minus 1, and this is called discount rate or discount factor. The notation that we are going to use for this case of model 1 are given here at the bottom. So you can go through it, you can just pause the video and go through the notation. So what is the present expenditure of n years? As we know that if a company buys a machine and then that machine requires certain maintenance every year, and the maintenance and operating cost goes on increasing every year, and if the company borrows money from a bank to purchase that machine and then pay for the maintenance and operating cost, then the company will have to ultimately pay back the borrowed money. Okay, so company wants to know what is the present expenditure of money spent on the machine on next 4 years, 5 years, and so on. Okay, so how this present expenditure on the machine is calculated? For this, we assume that R1, R1, R2, and so on up to Rn are the running costs during first, second, and consequently up to nth year. So if you want to calculate this present expenditure for n years represented by capital P subscript n, how we are going to do that? First of all, the cost of machine, capital C, capital cost of machine, plus R1, which is the running cost of machine during first year, and as this, R1 is the running cost during first year, we there will be no interest on it. Okay, so this will be simply v raised to 0. Then R2, so during second year, the discounted price of the running cost is v times R2. Similarly, the running cost during 3 years will have to be discounted by an amount by a multiple of v squared, and so on, and ultimately this the running cost of nth year can be computed by multiplying Rn by v raised to n minus 1. Okay, so this is how you can calculate the present expenditure of n years. Okay, so this is the same equation, and in this model we are going to assume that the salvage value is 0. So this is the replacement policy of this model, of this case of model 1, and there is a mathematical proof. You can go through the mathematical proof from any book. So this is the end result of that mathematical proof, that if the expenditure of the next year, or the running cost, sorry, not expenditure, if the running cost of next year becomes greater than equals to the uh, weighted average costs up to the nth year or current year, then we replace the machine. Okay, so this is the weighted average cost up to an nth year. And when we find that the running cost of next year, which is r n plus 1, is greater than this weighted average of previous cost up to current year or nth year, we replace the machine. Okay, so let us solve example based upon this. So on this slide, I am going to explain the tabular format that we are going to use for making calculations for this case of model 1. Again, this is the same condition from the previous slide. So let me give you an idea about the tabular format. In first column, we are going to mention the year number. So year 1, year 2, year 3, and so on. So I am writing up to 5th year, but this can go on depending upon the problem that we are dealing with. Then in column B, uh, we are going to write down or list down the running costs for every year. So running cost during first year, running cost during second year, third year, and so on. Then in column C, we are going to calculate this term on the right hand side, which appears in the numerator as well as denominator of the right hand side. In column D, we are going to calculate, just me. Okay. So in column D, we are going to calculate the product in the numerator, which is RR into V raised to R minus 1, which is simply the product of column B and column C. So this will be the product of column B and column C. Okay, so for this particular year, for year 1, this will be B2 second row, column B second row, and column C second row, B2 C2. Similarly, this will be B3 times C3, and so on. Okay, then in column E, we are going to calculate this sum in the numerator. Okay, so remember that this term, let me erase this. Uh, okay, so remember that this term, which refers to the numerator here on the right hand side, basically is the cumulative value of this term. Okay, so you can see this is the summation of r equal to 1 to n. So we will have to go on adding for this. So this will be C actually. Start from C, then this product for first. So we will add it. C plus that term will go here, then this plus this term will go here, this plus that term will go here, and so on. Okay, so because this term is cumulative. Okay, then in column F, we are going to calculate the cumulative discounted factor. So column F can be directly calculated from column C. So first term, let me use another color. So first term is will be same here. Then the second term in this column will be the sum of this first term plus the sum of the second term in this column. Then the so this is how the second term will come. Then the third term will be again the sum of second term in this column and third term in this column. Okay. So likewise, so this will go on. And finally, we will have the entire right hand side of this condition, and this will be simply column E divided by column F, because E lists down the numerator of the right hand side and F denotes the denominator of the right hand side, and hence the term in G will be the division of term in E of the respective row divided by the term in column F in the same row. Okay, so this term will be this numerator divided by that denominator. Okay, so that's how we'll go on. And then finally, what we are going to check is whether Rn plus 1 is greater than or equal to uh, the right hand side, which is represented by column G. So the machine will be replaced when we are looking at this column G, and Rn plus 1 running cost of each year is represented in column B. So what we have to do is we have to calculate this term on the right hand side for the first year and n plus 1. So compare this term with the Rn plus 1 running cost of second year, and if it turns out that the running cost of second year is greater than this term of the first year, then replace the machine of the first year itself. Okay, if it turns out it is not greater than, then we continue our calculation. Then we again calculate the right hand side for second year and then compare that with the running cost of third year, and again we check the condition. If the condition is false, we move on to the calculation during third year, and then again we compare it with the running cost of fourth year, and this will go on. Okay. So let us solve an example based upon this condition. Machine cost rupees 500. So 500 is the capital cost of this machine. So this is capital C. Operation and maintenance costs are 0 for the first year and increase by 100 every year. So that means they have given a way of formulating or way of calculating the running costs uh, for the upcoming year. So in the first year, the operation and maintenance cost is 0. The second year, the operation and maintenance cost increases by 100. Third year, it will be 200. Fourth year, be 300, and so on. So this will be our column of R subscript R. If money is worth 5% every year, so this is the interest rate. Okay, so this is 0.05 I equals to 0.05. Determine the best age at which the machine should be replaced. The resale value of the machine is negligibly small. So what is the weighted average cost of owning and operating the machine? Okay, so ultimately we want to find out when the machine should be replaced. So this is the given data. The capital cost of the machine is 500 and the interest rate is 0.5. I will always be less than 1. Okay. Okay, so let us begin calculations, and this is the same tabular format that we saw a couple of slides back, and this is the same condition for the replacement policy for this case of model 1. In column A, I have already mentioned the year number, so 1, 2, 3, 4 and up to 5, and I am writing only up to 5th year, or I am mentioning only up to 5th year uh, because we want to see whether machine is going to be replaced up to 5th year or not. Okay, if not, if we complete all the calculations and finally it turns out that this condition is not satisfied up to 5th year, then we will add more rows at the bottom of this table for 6th year, 7th year, 8th year, and so on until this condition is satisfied. Okay, so right now I am right. We will do computations only up to 5th year, and then we'll find out whether the condition is satisfied or not. Okay. Then in column B, I have mentioned the running cost. So for first year, the running cost is 0, and then every next year, the running cost increases by 100, and hence I am adding 100 every next year. Then let us start doing calculations. So this term v raised to r minus appears both in numerator and denominator. Let us calculate that term in C. So v raised to r minus 1, r equals to 1 for first year, uh, r equals to 1, so 1 minus 1, v raised to 0 is equals to 1. So this is 1. Then for r equals to 2, v raised to r minus 1, v raised to 2 minus 1 is equals to v1 is equals to 1 upon 1 plus I raised to 1 is equals to 1 upon 1 plus I is 0.05 equals to 0.9524. You can just pause the video and verify that value. 1 upon 1 plus 0.05 comes out to be 0.9524. Hence, this comes out to be 0.9524. Then similarly, when r equals to 2, v raised to 2 minus 1, sorry, r equals to 3, v raised to 3 minus 1 is equals to v square 1 upon 1 plus 0.05 squared is equals to, you should get this value as 0.907. Okay, so this way you can continue your calculations and verify that you get for r equals to 4 0.8638 and r equals to 5 0.8227. Okay, then move on to next column, which is column D, which is this multiplication, in numerator r times v raised to r minus 1, which is simply the the product of column B and column C. So column B into column C will be column D. Hence, for year 1, 0 into 1 is 0. For year 2, 100 into 0.9524 is 95.24, and so on. So if you do the calculations for r equals to 3, you should get that product as 181.4. For r equals to 4, 259.14, and r equals to 5, 329.08. Okay, then let's move on to column E. So column E is the numerator of the right hand side. So first is we add capital cost of equipment, which is 500 plus r into v raised to r minus 1. So when r is equals to 1, so this summation becomes r1 into r equals to 1 to 1, so n is 1, r equals to 1 to 1, so r1 plus v raised to 1 minus 1, so this is simply 1 into this is 0. Okay, we are already calculated this product, so which is 0, so 500 plus 0 is 500. Then for r equals to 2, this is again C plus 500 plus, now the summation r equals to 1 to 2. So the product, this product, we have to sum this product for first 2 years. Okay, so 0 plus 95.24. Okay, r, so this product summation will expand to r1 into v1 minus 1 plus r2, n is 2, hence r2 plus v raised to 2 minus 1. Okay, so 0 plus 95.24, let me write it. So this will become 0 for r equals to 1, for r equals to 2, 95.24. Okay, so that comes out to be 595.24. So in 1 0, this comes out to be 500, that comes out to be 500, this is 595.24. And similarly, if you go on calculating the values, then you should get for r equals to 3, 776.64, which is simply 595.24 plus 181.4, you should get 776.64. So 776.64 plus 259.14 will give you 103.1035.78, and finally 1364.86. So pause the video and verify those values. Then in column F, we are going to calculate the cumulative value of this term v raised to r minus 1. We have already calculated the values of v raised to r minus 1 in column C. We just need to add them. Okay, so r equals to 1 to n, r equals to 1, this is 1, r equals to 1 to n, so for n equals to 2, this will become r equal to 1 to 2. So 1 plus this term 0.9524 will be 1.9524 plus cumulative again, so 1.9524 plus 0.907 will give you 2.8594 and so on. So let me write the clean version: 1.9524, 2.8594, 3.7232 and 4.5459. Pause the video and verify those values. Finally, we calculate the right hand side of the inequality, which is simply column E divided by column F. Okay, so column E represents the numerator of this right hand side and column F represents the denominator. Hence for r equals to 1, this is 500 divided by 1 is equals to 500. For r equals to 2, this is 595.24 divided by 1.9524, which comes out to be 304.88. Okay, but before going ahead, we must check the condition. Okay, as we are ready with the right hand side, now we can compare the right hand side with the left hand side, which is column B. Okay, so for first here, let me bring the clean version of this. So this is 500, and we compare this with, as this is for r equals to 1, we compare this with r n plus 1, r2, which is here in column B, 100, and now we need to compare 500 with 100, and if you find out, we want to find out where Rn plus 1, where R2, whether 100 is greater than 500. So this condition is not satisfied at the end of first year, and hence we are not going to replace the machine after first year. Then at the end of second year, the right hand side becomes 304.88, and then we need to compare this with Rn plus 1, R3, which is here, which is 200, and again, as this is smaller, Rn plus 1 is smaller than that average, weighted average, and hence we are not going to replace the machine at the end of second year. Then third year, this value comes out to be 217.61, which we compare with the Rn plus 1, which is R4 this time, and now the condition is true. Okay, so Rn plus 1, 300 is greater than that 217.61, and hence we replace the machine at the end of third year. Okay, so manager can replace the machine. That will be the decision at the end of third year. Okay, so this is how the calculations work for this case of model 1, case 2 of model 1. Okay, so hopefully you have understood the calculations. In the next video, I'm going to present the model 2 of replacement theory. So see you in the next video.